Hey guys, Mr. Barnes here again, bringing another math video. This one I'm doing specifically for my grade 12 math class, and we've lost a number of days to snow days, so trying to catch up by doing a little online stuff. Alright, so in this lesson I'm going to give you transformations of exponential functions. In the last lesson we looked at the basic form of exponential functions. This we're going to expand on it. So if you remember from last day, from the last little lesson that I had, we looked at a c to the bx. So we're going to expand on that today by adding an h value and a k value. So hopefully that can give you sort of a little bit better of an idea of how this stuff works. So basically what your h and your k value represent are translations. So your h value is a horizontal translation, and your k value is a vertical translation. The a and b, we kind of found out that they have meanings as well. Last day we talked about a being sort of your distance between the asymptote and the y-intercept, and b being your x increment, or 1 over your x increment. Well, these also have other meanings as well. This is actually connected to the vertical stretch. Vertical stretch is equal to the absolute value of a, and the horizontal stretch is equal to the absolute value of 1 over b. So this is stuff that we learned before when we were doing translations. So the mapping rule stays the same. So all this stuff should be familiar to you. So this is the mapping rule 1 over bx. So 1 over bx plus h, a, y plus k. Alright, so let's do a few examples. So if we're going to graph something like this, I'm just noticing that I don't have any grids here for this. Actually, no, this is not a graph. So it says describe the transformations of each. Also identify the horizontal asymptotes, y-intercepts, domain, and range, and then write the mapping rule. So generally what I like to do with this stuff, a, b, h, and k. So your a value is -2. Your b value right here is 4. Your h value is -8. And your, sorry, that's not correct. Your h value is 6. So remember, for your h, the general form is x minus h. So you got to, it's already negative, so we take, some people like to think it's subtract, so I take a plus. And then my k value is -8. So that's my a, b, h, and k. So from that we can write the mapping rule. Let's get that out of the way. It's one of the most important things you need to be able to do for this unit. So 1 over 4 x minus, so minus our h value, and then it's ay, so -2y plus, or minus I should say, -8. So this is, again, this is a general form of the mapping rule. It's just 1 over b x plus h, ay plus k. So make sure you get that guy. If you don't know that for your public, then you should be in tears. Alright, so that's our mapping rule, so that's the first thing we need to take care of. So let's make some connections now. So horizontal asymptote. So this is new. In the last examples, they were always y is equal to 0. So the horizontal asymptote in these examples is your k value. So that's what it corresponds to. So in this guy, it's -8. So that's your horizontal asymptote. Basically, the graph was translated down 8. So it moved that horizontal asymptote of y is equal to 0 down to y is equal to -8. The second thing we have to consider is the domain and range. Well, the domain for these guys is always the same. X such that x belongs to all real numbers. So we always have that scenario where it's always all real numbers. Now the range is a little bit more complicated. So if you remember before, whenever we have just a basic y is equal to a c to the bx, we kind of have decay or growth, and we have a vertical asymptote, so everything's above that vertical asymptote. So we said it was greater than 0. Well, the thing about this is that we kind of have to watch out for reflections and things like that. So if you remember my little saying about reflections, so x by needs me x by. So if a is negative, well, actually I should write it like this, I guess, eh? So x by, so if a is negative, there's a reflection in the x-axis. So if you look at this guy, a is -2. So there's a reflection in the x-axis. So this is a decay graph because my b value, or my c value, sorry, is 1/2, so it's decay, but it reflects over. Now it's also, I have this vertical asymptote, so we have to take that into consideration. So if I just do a quick sketch of this guy, I have a vertical asymptote somewhere along here at -8. So everything should be below that line. So below that line means that, you know, it looked like this before, but because there was a reflection, it's going to look kind of like this. Alright, so that's, you know, similar to what it would look like. So everything for the range, so y such that y is less than -8, and then y belongs to R. So what we need to consider for the range is we need to know the horizontal asymptote. So that number right there is always going to be your K value or your HA. The only thing we need to consider is are there any reflections in the x-axis. So if A is negative, it's less than. So if A is negative, it's less than. If A is positive, it's greater than. Simple as that. So it just reflects over that line. The B being negative doesn't really affect it because it's just going to flip over that X. I'm doing all kinds of hands motion here because I'm on the smartboard, and it must just look ridiculous if someone's looking through the window watching me. All right, so, and I keep thinking that because I'm in my classroom, I'm teaching and people can see what I'm doing. So this is actually probably going to be the most ridiculous video you'll ever see. All right, I got 17 minutes to make this video before I got class. All right, so let's do this one as well. So A, B, H, and K. So we have an A value of 4, a B value of -2. So my A is positive, so there's no reflection. And my H value, so if you notice here, it's kind of the same song and dance as we always had. We need to make sure that there's a second set of brackets up here. Nothing can be touching that X. So I take a -2 out, and it looks like that. I should always do just a mental check. -2 times X, -2, and -2 times -5 is 10. So that's good. We did it right. So my H value in this case is 5, and my K value is 1. So my mapping rule is going to look like this. So it's 1 over B, so 1 over -2, and that's just -half, X plus H, so plus 5, and then AY, so 4Y plus 1. Now the next step is to go ahead and find the HA. So the HA is just K is equal to 1, so that means that Y is equal to 1. So the equation of the HA is always Y, make sure you put that in. And then I'll write the range. The domain is the same as the last one. So the range, so this guy doesn't have a reflection. It's actually not a growth curve. Even though this guy is 3, you have a negative here. So this is actually technically 1 over 3. So we can kind of be careful about that. See, a negative exponent means this is actually a 1 over 3 base. So we have to watch out. So this is actually a decay curve. So we have to be really careful about that. And we have negative exponents. So we have y such that, and because we have no A is positive, and my K value is 1, it's going to be greater than 1. So this thing shifted up 1, and then it didn't reflect, so it's just, you know, greater than 1. Alright, so hopefully that sort of explains. So let me just do a quick little note on decay. So remember that we did decay and growth. So a decay curve, if you're one of my students, you don't really have to write this down, just listen. But if you want to, you can, sure. So a decay curve looks like this. Growth curve looks like this. So if you have a negative B, so your negative B value is going to actually flip something. So if I have, say, so this is what like a decay curve like this. So if you have a base of 1/2, so remember that a decay curve happens between your base between 0 and 1. So if I have this, those two things are really the exact same thing, because a negative exponent, so 2 to the negative x, is actually just 1 over 2 to the x, because all it does is just flip my base over. So that's what a negative exponent does, it flips the base over. So that's important to keep in mind. It's not just based on a number, but if b is negative, you have to really consider if it's growth or decay. So another example is like this is a growth curve, 2 to the x. The b value is 2, it's greater than 1, therefore it's growth. Well, if I have 1 over 2 to the negative x, it's exactly the same thing, because that negative exponent right there flips over my base and makes it 2. So hopefully that sort of breaks up that idea of what's decay, what's growth. So it doesn't necessarily, now that we've introduced some more complex ideas, um, totally rely on what the common ratio, I guess it does really, because these are technically, I guess, these aren't simplified. So you just got to be careful and look for that negative. That's what I'll say. Alrighty, fun times ahead. Let's go ahead. I think I got a couple transformations that we got to do, and graph a couple of these guys. So if I have a situation like this where I'm going to have to graph this stuff, I need to break out my mapping rule. So A, B, H, and K. So my A value is 1 over 4. My B value is 2. My H value is 3. My K value is negative 5. Alright, so then I can write my mapping rule. So I have 1 over 2x plus 3, and I hate myself for choosing these numbers already. 1 over 4y minus 5. So that's my mapping rule right there. So in order to graph something with a mapping rule, we need a base table. So my base function comes from that guy right there. So my base function is whatever my c value is. So 1 over 4, I should write 1 over 4 to the x. So I need to come up with a table for this, so I can just literally pick the points myself. So anytime I have a fractional base that's less than 1, I usually start with a couple more negatives. So I'll start with negative 2, negative 1, 0, and 1. This is not like when you graph quadratics or other things with mapping rules. Generally, we don't have a lot of points because the points escalate really quickly. So I'll just work the first one out just to show you again, we got to be careful with the negative exponent. So negative 4, 1 over 4 to the negative 2, that's 4 squared, which is 16. So you see that point is not even on my grid, but it gives me an idea of, at least the shape of the graph. And then I'll have 1 over 4 to the negative 1, that's 4. 1 over 4 to the 0 is 1. And then I have 1 over 4. I'm just going to get another point just because, and that's going to be 1 over 16. So we're going to take these points, and I'm going to transform them. So it remains to be seen if this point transforms to something good on here. I'm praying that it will. 1 over 2x plus 3, and then 1 over 4y minus 5. So these points here are going to be pretty useless because they're going to be very small, but we'll still get an idea of what they're going to be. So this is just a calculator exercise, so I'm going to do this real quick. Negative 2. So all I'm doing now is I'm taking these values and I'm sticking them in for x. So I'm just going to do it real quick. So I'll do the one I can do the quickest first. 0 is 3. So that's going to be 2.5. Negative 2 times 0.5 plus 3. And that's 2. And then what do we got here? So I'm guessing we got a pattern going on here, guys. 3.5 and 4. So usually those are linear. They work out pretty good. 16 divided by 4 is 4 minus 5, negative 1. So that's actually a really, really good point. 4 divided by 4 is 1 minus 5, negative 4. 1 divided by, so that's 1 over 4. Subtract 5, so negative 4.75. And then we're starting to get a little bit complicated. So if any time you see that some of these points aren't working out that great, you might want to choose some different ones. 0.25 times 0.25 minus 5. So again, you're going to start approaching that asymptote. So you're going to get really, really close to the negative 5, which is the asymptote, but you're not going to touch it. So you can kind of guess where this one is going. So 1 over 16 times 1 over 4 minus 5. So it's really, really close to that asymptote. So if you want to get another point back, you could, but I'm not going to. I just don't have the time for this video. But if you want to work another point out, you can get negative 3 and then whatever that is, and then you can see if that gives you another better point. So let's just have a look at this graph now. So what do we got? 2 and negative 1. And we got 2.5. Let me see. Try it again. So 2 and negative 1. 2.5 and negative 4. And then we got 3, negative 4.9. And then, let me try. It's kind of hard on the smartboard here, guys, because my smartboard is not completely calibrated. So something like that. And I'll draw in my asymptote, which is at negative 5. And then my line kind of looks like this guy. Now I'm just remembering I didn't find a couple things in this. If I go back here, it asks me to find the y-intercept. I'm going to show you how to do it with this one. So I apologize for that. Alright, so next step is it asks us to give the domain a range. So domain's always the same. I'm not going to list it out. The range, so you can see there's no reflection in this guy. So A is positive, therefore it's greater than. And you can see that easily right here. It's a decay curve, and it's above the asymptote. So y such that y is greater than -5, y belongs to 0. So let's say someone wants you to find the y-intercept of this guy. So the y-intercept comes from x is equal to 0. That's the important thing to recognize with this. So if you always put in x is equal to 0, you will always find the y-intercept. So you go y is equal to 1 over 4 times 1 over 4 to x minus 3, let me write it, minus 5. So what I had to do is I had to sub 0 directly in here. So I get 1 over 4 times 1 over 4, and that's 2 times -3 minus 5. So that's to the -6 there. So again, this is a calculator exercise. Do this exponent first, bed mass, 0.25 exponent -6. And that's a really big number. It's 4,000 something divided by 4. And then minus 5. And we get a y-intercept of 1,019. So this thing just shoots up here really quickly. Okay? So there it is, guys. That's my transformation example. Let's do another one of these. So the important thing you take from it is your base table. It changes for every single graph. It depends on your base. Alright, so let's have a look at this guy. So A is 2. B is 2 as well. Your H value, sorry, that's wrong. Your H value is 2. Your B is -1 over 2, and your K is 5. I should also mention we're checking for brackets here. So we always double check for brackets. Those are important. So make sure you check for brackets. Check brackets. Brackets check. Alright, so once you get that, you can get your mapping rule done. XY goes to, and then we get 1 over B, so that's 1 over 2, so that's a -2, so basically flip this number. X plus 2, and then AY, so 2Y plus 5. And then we can go ahead now and write out your mapping rule and stuff. I'm going to leave this one to you guys because I'm running out of time here. I got class in 6 minutes. So I'm going to leave it. And if you got any questions about it, ask me in class. So I'm going to check this one to make sure you guys do it. But again, it's just the same motion. Go through it. So your base table is going to come from this time, just 3 to the x. So you just get your table from that. Don't worry about the fact that you have a negative there. That'll work out in the mapping rule. Okay? So yeah, so this looks like it's going to be a growth curve, but this is a decay curve. Alright. So, a lot of times word problems and such don't have a horizontal asymptote. So this is a common form for word problems. So that's something that you guys should look out for in your classes and on your public and things like that. So this is actually a really neat form to use. So it opens up a lot of different word problems. So let's have a look at this one. It says a cup of coffee is left to cool in a stadium. The coffee is initially 95 degrees Celsius and the stadium is 5 degrees Celsius. If the coffee cools at a rate of 6% every 4 minutes, determine the relationship that models the situation. And sketch a graph. So, if you have a cup of coffee and you leave it somewhere, it's going to go to the room temp. So if you leave a coffee in the stadium and it's 5 degrees in the stadium, that coffee will eventually get really, really close to that 5 degrees. So this is our asymptote right here. So that's our asymptote. So that's our K value right there. So in terms of your A, B, and K, so there's no horizontal translation. This one doesn't make sense. It starts at 0. That's why it kind of doesn't make sense to have horizontal translation. Some of these word problems, they all start at 0. So your A value, your B value, your K value. So we got your K value is 5 degrees. Now your B value, again, if you remember from the last lesson, that's always 1 over your X increment. So in this case, our X increment is every 4 minutes. So every 4 minutes this thing is going up. So really my B value is 1 over 4. So that's what number divides the X, 4. Now the other situation we have to really think about is your common ratio. So if you remember that if something's decreasing, it's 1 minus r. If something's increasing, it's 1 plus r. So it's 1 minus 0.06%. So my common ratio is 0.94. So let's sort of write out what we have so far. We have a c to the bx plus k. So we don't have our a value. Now it does say the coffee initially starts at 95. So that means that that's my y-intercept right there. My y-intercept. Excuse me. So what we need to think about is what happens if x is equal to 0. Well, in this form where you don't have an h value, if x is equal to 0, that thing disappears. And you get left with this. So a little formula that's useful for these word problems is that 95 is equal to, or sorry, the y-intercept, which is 95, is equal to a plus k. So if I have 95, and that's a, and my k value is 5, then a is equal to 95 minus 5, which is 90. Which makes sense because remember what I told you, the a value is the distance between the asymptote and the y-intercept, and there's the distance, it's 90 degrees. So this is my formula. Y is equal to 90, 0.94, x over 4. So I just like to think of that 4 as that's what number divides the x. I don't give a crap about this 1 over b stuff or 1 over 4. As long as you know that the x increment is a number that divides the x plus the k value of 5. And there it is. There's my formula. So the next thing I need to do is I need to put that 29 in here. So 90, 0.94, 29 over 4 plus 5. And I got 2 minutes left. 0.94 exponent 21 over 4 times 90 plus 5. So that's about 70-ish degrees or so. Alright, we got one question left there. If I was going to sketch this, guys, basically it would look like a decay curve. You'd have 5 going across like here, just go down like that, and your y-intercept would be 95. Same situation. Camel dies in the desert. What a depressing death. Where the temperature is constant. So the body is going to go to that temp. So that's so AY, C, BX plus K. So that's my asymptote. So the body cools at a rate 12% every 4 hours. So again, my R value, my C value is 1 minus R. So it's 1 minus 0.12, so 0.88. So that's my C value, 0.88. And my B value, or my increment, is 4, so that's x over 4. And then my A value is the y-intercept, that's the initial right here. So that's when that's the body temp when it dies. So my y-intercept is A plus K, or my A value is y-intercept minus K. So my y is 39 minus 25. So then you do the math on that, and then you get your 39 minus 25, you get your A value of 14. So there it is, 14. You can hear the bell going just in time. We get our formula, guys. So you guys can do the rest of this one. Sorry this video is a little bit rushed, but you know, I have a job that I have to make sure that I do. Thank you guys for watching, and I appreciate it. See you guys in class.